In this video we're going to continue looking at quadratic equations, and this is going to be quadratic equations part 3, the quadratic formula. Now, we use the quadratic formula on a quadratic equation where we've got x of the form ax squared plus bx plus c equals 0. And we'll assume that a isn't equal to 0 because then it would be linear, but a can be 1 as well. And here is our formula here. And I'm not going to prove it in this video, but if you want to see proof, look in the video responses at the bottom. I'm going to post that there for people who want to see the proof. And this part here has a special name. This part under square root, this b squared minus 4ac is called the discriminant. And we've got 3 different cases. It can be greater than 0, it can be equal to 0, or it can be less than 0. Now if it's greater than 0, we have 2 real roots. And in most textbooks they say it's 2 distinct roots, 2 distinct real roots. And if it's equal to 0, we'll have a repeated real root, meaning we only get 1 root instead of 2. And if it's less than 0, we'll get no real solutions, no real roots. And here's our graphs, just to show you what I mean by this. That's that one. That's that one. And that's that one. So there we go. There's our graphs. That's what the graphs look like for each one. And you can label them X and Y, but that's just a sketch to show you. So now I'll rub all of this out. So in these examples, this is what I want to do. I want to solve them and find the discriminant and see if it's rational or irrational. So we'll get the discriminant anyway, so we're just going to use the formula. So I'm putting these numbers in. This one here is A, this is B, and this is C. So I just put these numbers in the formula here. Minus B is minus 5. And we've got B squared, so we've got 5 squared minus 4 times 2 times 3 over 2 times 2. Then with arithmetic we can simplify this. So I get 25 there, and then here I get 24, so it simplifies to the square root of 1 over 4, and then I get 2 solutions. So that means x can be and you can calculate these if you like, and you'll find out that these come to that one there comes to minus 1, because we get a minus 4 over 4. This one we get a minus 6 over 4, so that's going to come to minus 2/3. 3/2, sorry. Or if you like, you can write it as that. So that's your first example there. So because of that, that implies that it probably factorizes. which is a pretty good way of checking that the quadratic formula is getting the right solution for you. And the discriminant in this case was 1. It came to be 1, so it was rational. Because we know the square root of 1 is rational, because the square root of 1 is 1. It's a perfect square. So okay, now let's look at the second example. Again, I'm going to put my numbers in. I've got minus 10 plus or minus 10 squared minus 4 times 3 times minus 4 over 2 times 3. And I get minus 10 plus or minus 100 minus, that's 12 times minus 4, that becomes a plus, so it's plus 48 over 6. So now we've simplified all of this, and now what we'll do is we'll see if we can simplify this square root bit here. And in this case, let's see if we can or not. We should be able to. That'll come out, let's see, I think the square root of 4 goes in there. So then we're gonna get minus 10 plus or minus the square root of, right, let's divide this by 4 and let's see what we get. We'll get 74/37. So we'll get root 4, root 37 and over 6. And then we can simplify. We know that that's 2. Now, we can cancel this a bit. I'm coming up here now. I'm working with this one. And now we can see in this one that we've got a 2 as a factor. We don't take out any factor underneath the square root. But we can take out this one in front. So now I'm going to factor out the 2 and I'm going to get minus 5 plus or minus root 37 over 3. And that's going to be the solution. And in this case the discriminant was 37, and we know that 37 isn't a whole number, so that's irrational. So for this one the discriminant was irrational, and this is your solution.